All right, eighth graders, not ninth graders. We are going to keep working on these notes. They are the second part of the notes. They'll be on page 65. We did the first part yesterday. So number 12, Discovery Place Preschool gathered data on the age of each student in years and the child's height in inches. The graph below displays the data that they gathered. So the first question, what is the input? Now remember, your input is your X value or your the independent variable. So our input, our X value here, the thing going into this function is the age. That's the thing they evaluate first. So we are going to say age. Now, what is the output? Well, the output is going to be a height. So if age is input and height is output, the question is the child's height a function of the child's age? I always want to see you underline a function of and then circle the following piece, because the following piece is going to be our input, that age. So the child's age, if it's going to be a function of the child's age, then every input will have exactly one output. So the question is, does every age give exactly one height? Well, let's look at this picture. What about the age of 2 years old? Well, there was a 2-year-old that had a height of approximately, I don't know, like 28 inches, 29 inches, 31 inches, probably 32 inches. So this one, two alone, has lots of different heights because there are 4 different 2-year-olds that don't all have the same exact height. And that's true of any age. If I were to ask all the 14-year-olds to stand up and we line them up, they would not all be the same height because your age doesn't necessarily determine a single height. So here I am going to say no. One age can have many different heights. It's very important to keep track of what they're talking about as the input and the output, because that's going to be critical in each problem that we do today. All right, on problem number 13, and actually the rest of the paper, you are going to determine if the relation or situation defines a function. And then right here it says justify your answer. It might help to make a second representation. So the following problems are going to be very similar to the ones that you will see on our upcoming test. We're going to ask you, is this a function? And you're going to justify why it is a function or why it's not a function. So what I'm going to keep checking is, does every input have exactly one output? Or if it's a graph, I'll check to see if it passes that vertical line test that we talked about. Okay, so I'm going to check my inputs on problem number 13. My inputs are 30, 45, 32, 30, and 41. Now there's one place that I want to look really closely. It's where the input repeated. So we've got 30 and 30. Now, if these are the same input, does 30 only give one answer as its output? Well, one of the 30s has an output of 2, but the other 30 has an output of 4. So on this one, it's asking, is it a function? We will say not a function. For my justification, I will say 30 has 2 different outputs. Now, I want to point something out here. I wrote the word different. That's because had it said 30, 2 and then another 30, 2, that would still be a function because 30 would always give us 2. It doesn't matter if it happens twice, so long as it's the same output. But because this one had 2 different outputs, it failed our definition of a function. Okay, so let's look at problem number 14, x equals 2. These ones are sometimes difficult because we're just given an equation and we're trying to decide what the graph looks like or maybe what the table looks like. So this is where we're going to probably want to make a second representation. I'm going to make a table of this. X and y. So my x values here, they just said are 2. So I have 2. And the output at 2, well, they didn't give me outputs. This is just saying x is 2, x is 2, x is 2. So that table is going to have 2's on the x's, and the y's can really be whatever you want. We could say 1, we could say 0, we could say 25, because it doesn't matter what the outputs are. The input is just 2. So the question again, is this a function? Well, does every input have exactly one output? What is the output for 2? Well, it's 1, it's 0, it's 25, it's tons of different numbers. So this one is not a function. 2 has multiple different outputs. I'd also like to remind you what the graph looks like for this. The graph would be on the x-axis at +2. I draw a dot there, and it would be a vertical line. That would fail the vertical line test because I can draw a vertical line that crosses all the points of that line. Okay, let's look at number 15. And on this one, we're given a graph. Now, whenever you have a graph, that's the only time you're allowed to use the vertical line test. You can't just say, oh, it passes or fails the vertical line test unless you draw a graph. So on this one, let's check the vertical line test. I'm going to draw a vertical line here, and you'll notice it crossed this graph in 2 different places. So because this vertical line crossed in 2 different places, I'm going to say not a function. My reason? Failed the vertical line test. Okay, problem number 16. I'm actually going to have you try 16 and 17. So push pause on your screen for a second, and I'm gonna let you try those, and then we will talk about them together in just a moment. So push pause, try 16 and 17. All right, on problem number 16. A, the input has 95 as its output. So far, it looks good because the input has one output. But then when I go to B, B has an output of 88 and also an output of 87. This is not a function. I didn't even have to check C, by the way. B has 2 different outputs. B has 2 different outputs. Failed our definition of a function. Okay, number 17. I hope you followed what we talked about with underlining and circling to figure out what the input is. So it says, is the number of pets you own a function of your age? And I'm going to write input next to your age. So let's think about that. If I have an age of, I'm just going to make a little table here. Let's say we have like a 15-year-old who has 1 goldfish. And then let's say we have a 30-year-old that has 1 dog. But then we have another 30-year-old that has 0 dogs. I want you to see that your age does not determine how many pets you have. 2 people who are the same age can have different number of pets. So I'm going to say not a function. And here's why. One age, like 30 or like 2 80-year-old women, one age can have many different amounts of pets. Your age does not say one amount of pets is allowed. That would be really weird. I would like you to try the rest of the paper. Try 18, 19, and 20, and then we'll review them together in a moment. So push pause. Okay, on number 18, is the area of a square a function of the side length? So that is my input. So if side length is the input, the area is the output. I'm going to make another representation. So let's say that I've got a square and the side is 1. Well, to get the area, I would need to do 1 times 1 for those 2 sides, multiply them, and I would still get 1. Okay, that's the only answer I could get. If I had a square that was 2 inches, I'd do 2 times 2, and that area would be 4. If I had a square that was 10 inches or feet or whatever, and I were to find the area, that would give me 100. So you're noticing that every side length maps to exactly 1 square, which is perfect. That actually makes sense because you wouldn't want a square that had a 2-inch long side to sometimes have an area of 4 and sometimes have an area of like 5. That would be impossible and really weird. So this one is a function. I'm going to say, yes, each side length has exactly 1 area. Each side length has exactly 1 area. Okay, let's look at number 19. The length of a radius. Now, a radius is like on a circle. That's the radius. And then the length of the diameter. So every radius here, they're listed out. They're telling you the diameter of it after. Well, the diameter would be all the way across a circle rather than halfway across a circle. You can see that 0.5 has a diameter of 1. A radius of 1 would give a diameter of 2. 1.5 would give a diameter of 3. 2 would give a diameter of 4. This one, yes, it's a function. Each radius gives 1 diameter. Okay, number 20, the name of a city in the United States and the input is the name of the city and the output is the state that the city is in. Here's a little hint though. There are 16 states in the US that have a city called Independence. Okay, so if I think about this, that input is the name of the city. So let's use that example of Independence. That's the input. But the output is all these different states that have the name of a city of Independence. Same with something like Springfield. There are tons of Springfields or Springvilles or whatever, and they're in many, many, many different states. So the name of a city does not necessarily give one exact state. So this one, not a function. And I'm going to say one city name can have multiple states as outputs. All right, try the practice for today and let me know if you have any questions.